The human brain is a dense landscape of organic circuitry. It functions as an endlessly firing network of billions of neurons that evolved over millennia to ensure our survival. Yet, for many of us, this refined biological machinery seems to short-circuit the moment we encounter a complex algebraic equation. We are typically taught math in rigid environments, where it is presented as a cold language forced into memory through constant repetition. This shared anxiety leads to a common assumption. The human brain was never built to perform mathematics. That assumption ignores our evolutionary history. If mathematical ability didn't originate in the classroom, we have to look for its actual biological source. Finding that source requires looking at the very beginning of human development, long before any formal schooling begins. Humans possess a cognitive trait called subitizing. This is the instinctual ability to recognize small quantities the moment we see them, without needing to count one by one. This trait is innate. Researchers have observed it in infants before they acquire language or receive any mathematical training. We enter the world with a foundational mathematical brain. The mystery lies in where these biological instincts end and our cultural inventions begin. To find that boundary, neuroscientists look directly at the physical structure of the cortex. As you can see in this anatomical model, researchers have mapped our innate number sense to a region called the intraparietal sulcus. This is our biological math hardware. This module acts as a rapid magnitude estimator. When you look at 3 objects next to 4, it immediately processes the difference in quantity. However, this biological hardware reaches its limit quickly. If you look at 47 objects next to 48, your subitizing fails. You must stop to manually count. Neuroscientists can observe these boundaries in a lab, measuring the precise moment our hardware fails to process high-resolution quantities. Our innate number sense is a survival tool for estimating the world, but it hits a hard ceiling defined by evolution. To bypass that ceiling, human civilizations invented cultural scaffolding, tools designed to offload our mental limitations. Thousands of years ago, this took the form of physical objects, tally marks carved into bone, or clay tokens used to track grain. Over centuries, these tokens evolved into sophisticated devices, allowing early accountants to perform arithmetic well beyond their biological capacity. Eventually, we developed the most efficient tool of all, abstract Arabic numerals and written equations. This created a neurological hack. When you learn math today, you are training the visual and language centers of your brain to map these cultural symbols back onto your ancient number module. Calculus and trigonometry function as advanced cultural software running on a primitive biological operating system. We can see how reliant we are on that underlying hardware by looking at a condition known as dyscalculia. Dyscalculia presents as a structural deficit in the innate number sense module. It occurs independently of a person's general intelligence or their level of effort. This logic model shows the difference. In a neurotypical brain, a written symbol triggers an understanding of a physical quantity. In a dyscalculic brain, that mapping pathway is disrupted. This causes immense frustration in the classroom, as a student is asked to run complex cultural software on hardware that cannot read the code. This condition proves that mathematical ability originates in our physical brain anatomy. This brings us back to the problem of math anxiety. Traditional rote memorization often fails because it attempts to train the software while ignoring the biological hardware required to run it. Modern education is shifting to root abstract equations in physical quantities, in spatial relationships, and visual formats that our innate hardware naturally understands. This understanding dismantles the myth of the math person. Barring a specific structural deficit, every human possesses the anatomical equipment required for mathematics. We are biologically engineered to understand the logic of numbers.